Today we're going to talk about medians and altitudes of triangles. Your vocabulary for today is median of a triangle, centroid of a triangle, altitude of a triangle. Here, a median. So we use the centroid to. For this example, we have a triangle JKL where ZW is equal to 7 and LX is equal to 8.1. So I labeled XL or LX 8.1 and we want to find LZ. So the centroid theorem says that LZ is equal to 2/3 of LX. If I substitute 8.1 for LX, then we get that LZ is equal to 2/3 of 8.1. Plugging that into a calculator and simplifying, we get LZ is equal to 5.4. For this example, we have triangle JKL where ZW is 7 and LX is 8.1, and we want to find KW. The centroid theorem tells us that KZ is equal to 2/3 KW. WZ plus KZ is equal to KW by segment addition because the two small pieces of a segment add up to the whole segment. We can go ahead and subtract WZ from both sides, and that gives us KZ equals KW minus WZ. Substituting KW minus WZ for KZ, we get KW minus WZ equals 2/3 KW. If we substitute 7 for ZW, we get KW minus 7 equals 2/3 KW. And then subtracting 2/3 KW from both sides and adding 7, we get 1/3 of KW is equal to 7. And multiplying both sides by 3, KW is equal to 21. So really what we're saying is, if we have, I know that was a lot of math and a lot of manipulation, really what we're saying, if 7 is 1/3 of the line, then the whole line would be 21. Because if ZW is 7, that's 1/3 of the line, and ZK is 2/3 of the line. So if ZW is 7, KW has to be multiplied by 3, and that's going to be 21. An altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Every triangle has 3 altitudes. An altitude can be inside, outside, or on the triangle. In triangle QRS, altitude QY is inside the triangle, but RX and SC are not. Notice that the lines containing the altitudes are concurrent at point P. Remember that concurrent means they intersect. The point of concurrency is the orthocenter of the triangle. The height of a triangle that you learned back when you started doing triangles and you were doing area of a triangle, the height of the triangle that you would have used for the area formula is the length of an altitude. Here we want to find the orthocenter of XYZ with vertices 3, -2, 3, 6, and 7, 1. So first thing we do is graph our triangle. Now we want to find an equation of the line containing the altitude from Z to XY. Since XY is vertical, the altitude is horizontal. The line containing it must pass through Z, 7, 1, so the equation of the line is y equals 1. So we see here we have a perpendicular that goes through Z, and it's the line y is equal to 1. And this one was easy to find because it makes that nice right angle with the graph. It's right in line with the graph because we had a vertical line. For this one, it's going to be a little bit more difficult. First, we have to find the slope of XZ. The slope of XZ is 3/4 using our slope formula. Remember, that's change in y over change in x. The slope of a line perpendicular is the negative reciprocal. Remember, we turn the fraction upside down, so it's 4/3, and make it negative. We need to use point slope form to find our equation. So we use m for the slope, x1 and y1 for the point, and we plug those in. So we plug those into our equation. Y minus 6 equals -4/3, x minus 3. And then we can distribute that -4/3 and add 6 to both sides to get y by itself. That's what we call slope-intercept form. Hopefully you guys remember how to do that. If not, you can ask questions before school or during lunch. So now we need to solve the system to find the coordinates of the orthocenter. So y is equal to 1. So we take 1 and put it in for y. So 1 is equal to -4/3 x plus 10. Subtract 10 from both sides, and multiply by 3 over 4, -3 over 4, to get our final answer. So x is equal to 6.75. Now, the point of the orthocenter is has to have two coordinates, so you have to have the x and the y coordinate. So the answer would be 6.75, which we got from the x, and the y equals 1 from the top gives us our y coordinate, so that's where we get the 1 from. And if we look at our picture, we can see where the two cross, and that is at 6.751. Now we want to show that the altitude of JK passes through the orthocenter of JKL. So here we have an equation of the altitude JK, and we want to see if it passes through the point -2, 4. So we plug in -2 for x, because our coordinate is x comma y, plug in -2 for x and 4 for y. -1/2 times -2 is +1, the 2's cancel, and 1 plus 3 is in fact 4, so it does pass through the orthocenter. We're really just seeing if the point -2, 4 is a solution of that line. Here's your lesson quiz. Go ahead and take some time and practice these, see if you have any questions, and if you do, go ahead and ask during class tomorrow, and we'll continue with some practice.